Hello class, welcome back. Today we are going to study types of reactions. And under this type of reaction, we are going to study precipitation reactions, acid-base reaction, gas evolution reactions. And if we have time, today we'll do oxidation and reduction reactions. Otherwise, we'll do oxidation and reduction reaction next class. Precipitation reaction, reaction between aqueous solution of ionic compounds that produce an ionic compound that is insoluble in water. So that is a precipitation reaction. And this insoluble product is called a precipitate. So for example, look at this reaction, the reaction of potassium iodide plus lead nitrate to produce lead iodide, which is a precipitate, and potassium nitrate. So this is it. This is the aqueous solution, where when you mix it, produces a precipitate, which is insoluble. You can see it here. Insoluble product. So how do we predict the product of a precipitation reaction? We'll take an example. Write the equation for the precipitation reaction between an aqueous solution of potassium carbonate and an aqueous solution of nickel chloride. So we'll write the formula of the reactants first. So these are the formulas of the reactant: potassium carbonate aqueous, nickel chloride aqueous. Then we try to determine the ions present in this reactant. You see, these are the ions. You break it, we have potassium plus and carbonate. We have nickel 2 plus and Cl minus. Then we exchange these ions. So you see, I've taken a cation and an anion. So potassium here, I match it with chlorine. Then nickel here, I match it with carbonate. So we write their formula, cross charges, and reduce, so that we write the correct formula for each of them. We write their correct formulas, balance charges. So these are the correct formulas. Then we go to the solubility rule and find out what these are. Is it aqueous? Is it solid? Is it gas? Now we are going to our solubility. So determine the solubility of each product. From our solubility rule, all group 1 compounds are soluble. But the carbonates, they are insoluble except those of group 1. So making this insoluble. So if both products are soluble, write no reaction. But because this is insoluble, there is a reaction. So this reaction is a precipitate reaction. It's insoluble, that's a precipitate. So write aqueous next to soluble products and S next to insoluble product. So you see, we'll write this. Then we try to balance the equation. So that is it. So we know that this is a precipitation reaction because after the exchange, we have a product which is insoluble. Let's take another example. Predict the product and balance the equation of the reaction of potassium chloride plus silver nitrate. We'll go through the steps. This is the formula of the reactants. Now we want to separate them in ions. So you see, from this, then we exchange. You see, we are exchanging. After we have exchanged, we want to balance the charges and write the formulas. So when we write it, this is it. So now we'll go to solubility table to predict the state. Is it aqueous? Is it a gas? Something like that. So from our solubility table, it shows that this is a precipitate. So it means this reaction is a precipitation reaction. Let's try this one. We'll do the same. We'll break it. We exchange the ions. The next stage, we want to write the formula by balancing the charges. So we balance the charges. Now we go to our solubility table to check the state. Is it a solid? Is it a liquid or a gas? Balance the equation. Then when we check, we notice that all of them are aqueous. So no reaction. No reaction. It means the ions are just moving around in solution. No reaction. I want us to examine ionic equations. Ionic equations are equations that represent the chemical product and reactants as molecules. Now, we want to look at ionic equations. Equations that represent chemical products and reactants as molecules are called molecular equations. So this is a molecular equation, we say. But when we start breaking them into their ions, then we have an ionic equation. So let's say an ionic equation. Equations that represent the actual dissolved species are called ionic equations, where we see the ions moving freely in solution. So aqueous strong electrolytes are written as ions, soluble salts, strong acids, and strong bases. Insoluble substances, weak electrolytes, and non-electrolytes are written in ionic equations as molecules. Don't break them up. I'll go back again. In an ionic equation, soluble salts, strong acids, strong bases, which we consider as strong electrolytes, are written as ions. But insoluble substances, weak electrolytes, non-electrolytes, are written in their molecular forms. Please don't break them. For example, this equation above, if we want to write the ionic equation, you see this is a strong electrolyte. You see, we have broken it down. This is a soluble salt. You see, we put it in the ions. This is a soluble salt in the ion, but this is insoluble. We must write it in the molecular form. But this is the ionic equation. Ions that are both in the reactant and products in the ionic equation are called spectator ions. So for example, let's look at this. You see potassium. You find it in the reactant side and the product side. Then you see nitrate. You find it in the reactant side and the product side. These are spectator ions. So an ionic equation in which the spectator ions are removed are called the net ionic equation. So when you remove the spectator ions, you have the net ionic equation. So let's take another example. Write the ionic and net ionic equation for the reaction K2 sulfate, potassium sulfate plus silver nitrate to give potassium nitrate and silver sulfate. So this is the ionic equation. And the spectator ions, we'll look at what is on both sides. So when we remove the spectator ions, we have what we call the net ionic equation. So this is the net ionic equation. So that is it with precipitation reaction. Now we want to look at acid-base reaction. An acid-base reaction is a reaction in which the acid reacts with a base to produce salt and water. Another name for acid-base reaction is neutralization reactions. Example, nitric acid plus calcium hydroxide to produce calcium nitrate and water molecule. So the net ionic equation for acid-base reaction is H plus OH minus to produce H2O. As long as the salt that is formed is soluble in water. In acid-base reaction, acid ionizes in water to form H plus ions. More precisely, the H plus from the acid molecule is donated to a water molecule. So we have what we call the hydronium ion. Bases dissociate in water to form hydroxide ions. So in the reaction of an acid with a base, the H plus from the acid combines with the OH from the base to make a water molecule. It's a liquid. The ions are not free. So the cation from the base combines with the anion from the acid to make a salt. So this is another example of an acid-base reaction. HCl plus sodium hydroxide to form sodium chloride. This is a salt. And water, which is a liquid. So you can see it. That's the equation, the balance equation. We want to look at some common acids. These are some common acids. Perchloric acid, nitric acid. So this is a list of some common acids. So you see we have 1, 2, 3, 4 very strong acids. Generally there are others. You have hydrogen bromide, is a strong acid, and hydrogen iodide. Then these are moderate acids. Then These other ones are weak acids. Strong bases, most of the time group 1 and group 2 hydroxide solutions are strong bases. So you see, sodium hydroxide is a strong base, potassium hydroxide is a strong base, calcium hydroxide is a strong base, sodium hydrogen carbonate is a weak base, magnesium hydroxide is a weak base, ammonium hydroxide is a weak base. So we want to write the formula of molecular, ionic, and net ionic equation for the reaction of aqueous nitric acid with aqueous calcium hydroxide. So let's see how that goes. So these are the reagents. We want to determine the ions present in each reactant dissociates. So from nitric acid, this is what we got. From calcium hydroxide, this is what we got. Then we exchange. So we have exchange. So write the formula of each salt. So that is the salt. Balancing the charges. So see, that is what is driving the reaction. So we want to determine the solubility of the salt. Calcium nitrate is soluble. So write S after the insoluble product and an AQ after the soluble product. So we are going to write AQ. We see this is L, so this is what is driving the reaction. So try to balance the equation. So when we balance the equation, you see we put 2 here and put 2 here. Now we want to eliminate the spectator ions. So let's look at the spectator ions. This is one. This is another one. Yeah, you can see them here. So when we eliminate the spectator ions, what do we get? The net ionic equation. So this is our net ionic equation. You can either write it like this or you write it like this. Let's take another example. Predict the product and balance the equation. So we are going to find, break the ions and exchange them. So this is what we got from HCl, barium hydroxide, this, and we exchange them. That's what we got. Now we want to balance the charges and write the formula. See, this is what we got. But now, is this soluble? Yes, based on our solubility rule, this should be soluble. So this is only what will stay as a molecule. So you see, it's aqueous. So this is our equation, and this is our net ionic equation. No. This is our ionic equation. This is our ionic equation. So this is our equation, and when it is balanced, this is it. So we have done precipitation reaction, we have done acid-base reaction. Let's look at gas evolution reaction. Some reactions form a gas directly from the ion exchange. Other reactions form a gas when the decomposition of one of the ion exchange products into a gas and water. So other reactions can form gases by the composition of one of the ion exchange products into a gas and water. So let's see. So let's look at this reaction. Potassium sulfide plus hydrogen sulfate to give us potassium sulfate and H2S. This one forms a gas molecule directly. But some, the product like this one, will decompose. You see, it decomposes. And this is what is given as a gas. This is the gas that's produced. So another example is this one. Reaction of hydrogen carbonate plus HCl. They produce sodium hydroxide plus H2CO3 aqueous. But this decomposes to H2O liquid plus CO2 gas. So it's this thing that is produced from the exchange that breaks down. So compounds that undergo gas evolution reaction. Metal sulfide react with acid to produce hydrogen sulfide. No decomposition, gas is produced. Metal carbonates and metal hydrogen carbonates react with acid to produce this, decompose it to produce carbon dioxide. Metal sulfide or metal hydrogen sulfide react with acid to produce this, that decomposes to produce sulfur dioxide gas. Then ammonium and anion react with base to produce ammonium hydroxide, which decomposes to produce ammonia gas. You can see examples of some of the reactions here. So these are some of the examples. So take and look at them. So let's go through an example. When an aqueous solution of sodium carbonate is added to an aqueous solution of nitric acid, a gas evolves. Write a balance equation for this reaction. Write the formula of the reactants. So this is the formula of sodium carbonate, and this is the formula of nitric acid. Determine the ions present when each reactant dissociates or ionizes. So this is the ions when this reactant dissociates. Exchange the ions. So exchange the ions. So write the formula of the compounds. So write the formula, the same. Write the formula. Then go to your solubility table and check. So solubility table tells us that this is aqueous and this is aqueous. There is none. This is not formed. So check to see if either product decomposes. So when you check, you will see that this will decompose to form this and this. So this will be a gas will produce. So your equation, the correct equation is this. You cannot leave it like this. This is not correct. So determine the solubility of other product. This is soluble. So write an S after an insoluble product, and aqueous after a soluble product. So aqueous, gas, gas. Balance the equation. So this is our balance equation. Let's take another example. Write the product of the following reaction and balance the equation. So this is the reaction. So this is the reaction. Please try and do this at home. So summary of other reaction types. So we have precipitation reaction, acid-base reaction, gas evolution reaction. All involve exchange of ions. So there's another type of reaction which does not involve exchange of reaction, and that is oxidation reduction reaction. So we'll come to this next class. Thank you.